For the first 5. Take a look at those and see if we need to go over any of them. Number 4. On number 4, they started out with a grid. And in this grid, it was 9 grids by 6 grids, right? It was 9 by 6. And they said that this one was at a ratio of 1 to 4. So this would have been 36 meters, and this would have been 24 meters. And they asked me to redraw it at a rate of 1 to 6. 1 centimeter to 6 meters. To do that, I've got to take each one of these numbers and divide it by 6. Because now I'm going to go from meters to a new drawing. 36 divided by 6, this would have been 6 units long. 24 divided by 6, this would have been 4 units long. And it really wouldn't have mattered where I gridded that on that grid paper, so long as it was 6 units by 4 units. In part B, they asked me to compare the actual dimensions. Well, this is still 36 meters by 24 meters. So you'll notice that both of them are what? The same. That way I know for sure that both scale drawings are correct. That's what they were looking for you to do. Compare the two of them. Okay? Any others in that first group? Number 5. Okay, number 5 says, if you have an accurate, complete scale drawing and the scale which measurements of the object of the drawing can you find? And the truth of it is no matter how they draw it, if you've got an accurate scale drawing, then you can find, and the scale, you can find all of the measurements of any shape, no matter how many sides it would have. Because if they tell you the ratio, or the scale is, let's say, 1 to 5, 1 inch to 5 feet, and they give you a drawing, and it has all the dimensions on it, 2 inches, 7 inches, I can find the actual size of the original object because they gave me that rate at which it's going to change. So no matter what kind of shape it is, it wouldn't make any difference. So long as they've given you an accurate scale drawing, you can find all of the missing measurements in the real figure. Okay? Any others from the first group? There is 6 through 10. I was asked for number 6. Number 6 says, her copy has dimensions of 2 inches by 1.5 inches. And it says the scale of the copy is 1 inch to 40 centimeters. Remember that anything can be set up in a proportion. If I've got inches compared to centimeters, I want to make sure that I'm comparing inches to centimeters. And I would actually cross multiply. 1 times x is obviously just what? Just x. And then I'm going to take 2 times 40, which is 80. So I'm going to have 80 centimeters for one dimension. And then I'm going to do the same thing on the other one. 1 over 40 equals 1.5 over x. And again, I'm going to take the 1 times x, which is just x, and 40 times 1.5, which is 60. So my question A says the original dimensions. It's 80 centimeters by 60 centimeters. To find the area, we'd multiply those two together. 80 times 60 is 4,800. Remember that when you're talking about area, it's no longer just centimeters, but it's really centimeters squared. Part C was really the trickier part. In part C, remember, if I had 80 centimeters by 60 centimeters, part C said that 1 inch is the same as 2.54 centimeters. So, if that's my scale, 1 to 2.54, I can find out how many inches this 80 centimeters is by making sure that I get it in the right spot in my proportion. I'd take 1 times 80, which is 80. I'd take 2.54 times x, which is 2.54x. And what am I going to do to get x by itself? Divide by 2.54. Now, obviously, that's not going to go into that evenly, and so I rounded to the nearest tenth. I got 31.5 inches. And then I did the same thing. 1 over 2.54 is equal to x over 60. Again, 1 times 60 was 60. 2.54 times x was 2.54x. And I divided both sides by 2.54. And x was equal to, again, it didn't come out evenly, but I rounded to the nearest tenth, 23.6 inches. And in part D, I again multiplied these because they were looking for the area, 743.4. And again, if it was in inches, area is in inches squared. Okay? 10b. I think to do 10b, I've got to make sure that I do 10a as well. I think it's written that way. It's actually not, I don't think. If the original building is 810 meters tall, what is the scale used to find it? So if the scale is 5.4 feet, and it's compared to 810 meters. In order to really do this, I can't have a decimal in a fraction. If I move the decimal one place in my numerator, I have to move it one place in my denominator as well. This is still feet and meters. If I divide 54 into 81, this would be 1 foot, and this is going to go into it actually 150 times. That's part A. 1 foot is the same as 150 meters. In part B, it says if the model is made out of tiny bricks, each measuring 4/10 of an inch in height, how many bricks tall is the model? Well, it said it was 5.4 feet tall. I've got to change the feet into inches, so I took 5.4 times 12 to find out how many inches tall it was. 5.4 times 12 is 64.8. And if it's 64.8 inches tall, and I'm going by 4/10 of an inch, I'm going to divide that by 0.4, and I'm going to find out that it is 162 tiny little bricks tall. If the bricks are to scale, how many bricks tall is the building? Anybody know? If the bricks are to scale, think about it. If the bricks are to scale and the model has 162 bricks, from top to bottom. How many is the building going to have? No. It's a good question, guys. Should be able to answer it. Oops. Number 8 says the length of a table is 6 feet. On a scale drawing, it is 2 inches. So they're saying 2 inches compares to 6 feet. They said write 3 possible scales for this drawing. Well, there's one of them. But what'll go into both 2 and 6? 2 will go into 2 how many times? Once. It'll go into 6 3 times. So there's a possibility. It's possible that I could have multiplied this. I might have compared 2 times 2, which is 4, and 6 times 2, which is 12. I could have done that. I could have changed 1 inch. 3 feet's the same as a yard. I could have compared 1 inch to a yard. How many possibilities could I write? Infinite. Others. Yep. Number 7. Number 7 says the game room has a floor that is 120 feet by 75 feet. And if they said uses a scale of 1 unit to 5 feet. Well, if I have 1 unit compared to 5 feet, then I'm going to have so many units compared to 120 feet, and I would cross multiply. 120 times 1 is obviously 120. 5 times x is 5x, and I would divide both sides by 5. And x is going to be equal to 24 units. And I'm going to do the same thing. I'm going to compare 1 to 5. It would be the same as x to 75. Again, I'd take the 75 times the 1, 75, and the 5 times the x, 5x, and I would divide both sides by 5. And x would be 15 units. Okay? Anything else? Once, twice.